Hello all. So let's continue with the coin change problem as we discussed in the last class. So very briefly we discussed. So let's see the problem once again, that we are given a coins array and each of the element represents the denomination of the coins that we have. And we have to make the amount in such a way that minimum number of coins are used. Okay, so you are given in coins array representing the different coin denomination and the amount. Okay, and return the fewest number of coins that you need to make up to that amount. And if you can't make it, then just return -1. For example, this case, we just have coins of 2 and we have to make amount 3 and we know that we can never make it. So just return -1. And the most important thing, that you have to assume that you can use each coin unlimited number of times. Okay, so it's a very simple problem. And as we already discussed, that greedy will fail in this case. So we already knew this, that if we choose just the highest coin, then it will work in this case of 1, 2 and 5. But if we consider one more edge case, which is this one, which we already discussed briefly, that if we have 2 and 5 and we have to make 6, then choosing greedy is not the solution. If we just use 5, then we are not leading to the solution, because after this we are stuck. But we know that with the common sense that okay, we can use the coin 2 thrice and we can get 6. So every time going for the maximum coin directly doesn't work, and that was our greedy solution which failed. And as I said, if greedy fails, then go for exhaustive. And in that exhaustive, if you find repeated subproblems, then go for dynamic programming to save those many recursive calls which are repeating. So as we said, greedy failed, so let's go for the entire recursive or the exhaustive way. So in order to get to that exhaustive way, I'll come to this later, but let's go for the exhaustive way. Okay, just ignore the previous slide. I just wrote for saving of our time. So let's grow the entire tree like we did for Fibonacci. And here I will show you what are exactly those repeated subproblems. So at every coin, let's say we are choosing, you can start with any coin, just a disclaimer. You can start growing the tree from 5 or 2, or even the order is changed. Like for example, I am given 5 and 2 or 2 and 5 and the amount is still same. You will get the same answer by following the same approach. So that's your homework. After you grow this tree, okay, that is I'm growing, go for this 5 and 2 or change to any order. Okay, other than 1 to 5, go for any other order and grow it, and you should get the same answer. Okay, so and the intuition is clear that why we will get the same answer, because at the end we are going exhaustive. We are choosing each and every case that is possible, like choose, not choose, choose, not choose. So what does 0 means? 0 means that we are not choosing. So not choose. So it means right now we started at from 1, so it means that we are not choosing 1, and 1 means we are choosing. That's the only difference of writing 0 and 1. Don't confuse it with this 0, this 1 coin. Okay, this is a denomination of the coin, and this is like choose, not choose, like binary 1. Okay, so instead of this we can have any other one as well, but here it's always 0 and 1. Okay, just don't confuse yourself. So if we don't choose, then we know that we are just left with 2 and 5, and the amount still remains 11. So this is not the power, this is the amount. And if we choose, then we know that we can choose the same coin unlimited number of times. So we are still left with all the coins, but the amount is reduced by 1 because we have chosen coin 1 with denomination 1. So now let's grow further. For example, let's grow from here. Now we are having 0, 1 case again. Let's not go to 0 case. Let's go just to 1 case. You can go for 0 case, but just to save time, I'm not. So we are getting 2, 5, and since we are using coin of value 2, we are reducing our amount by 2. Same thing, you can go for here 0, 1, and since we are not choosing 1 now, we are left with 2, 5, and the amount is 10. And if we are choosing, so it is this branch, then still we are left with all the 3, but the amount is reduced by 1, which is 9. Again 0, 1. So in the 0 case, since we are not using, we are getting 2, 5 and 9. And in 1 case, still everything, and we are getting the amount 8 since we are choosing. So if you will now see I'm not growing the entire tree just for time purpose. So this point and this point, beyond this point if you grow, okay, and beyond this point if you grow, it will be the exact same tree that you will grow from this point. So we have identified our repeated subproblem. And if you'll grow the entire tree, you will get a lot of such repeated subproblems. And thus we can conclude that we can use our dynamic programming approach. So I'll also code, I won't jump directly to dynamic programming. I'll also code this exhaustive solution, and which will give us time limit exceeded for sure. Okay. So if you run this on Leetcode, you will get time limit exceeded. Although in the constraint, they haven't mentioned anything that you should solve in this time, but this will give time limit exceeded. And what will be that time complexity? So for example, if I just always choose coin 1. So if I continue this, like choose, then at the end I'll be left with, I'll be done with the amount, my amount will be 0, and this will be 11 times, right? So 11 times, what will be the depth? This will be 11. But let's go just one step further, so one step back. For example, one of the case will be we will get 1 to 5 and our amount will be still 1. Now if I don't choose, if I go to the don't choose side, then we are left with 2 and 5 and amount will still be 1. Okay, let's remove this stylus from here. And okay, let's also go a bit above. Okay, I know that some of the screen is cropped, but I think that should be fine. And if you still grow from here 0 1, then you are just left with 5 and amount is still 1. And if you still grow, you are left with nothing, all the coins are gone, and amount is still 1. Okay, so the maximum depth, if you wonder, it's not just 11, or I can say amount. Maximum depth is not equals to amount here. If you just go one step further, one step back, okay, and grow the tree again, then you will get the 2 more depth. Okay, so it will be always 2 power amount plus coins. I mean total number of coins. So this will be a really huge number for larger amounts, and also when we have a lot of coins. And that's why we will get time limit exceeded. And we know that we are not going to solve this as the optimum version, because time limit exceeded is not something that we want. And that's why we are going for dynamic programming. And as I said, we have 2 methods. One is memoization. I don't know why they call it memoization. It should be something like memorization, but if they are calling it, let's call it. Another is tabular approach. The idea remains the same. In memoization, also we store the value of this repeated subproblem. So whatever answer that we get by growing this tree, whatever answer that we get, we are just storing it in hash map or anything, right? And then we are always using that when we encounter that again. For example, we are encountering it again, we are using this so that we are saving a lot of recursive calls down the line. And in the tabular form, it's the same, that we are also saving. But tabular form is really easy to visualize and understand. That's why I'm going for tabular approach. And you will see that I have used one extra dummy amount, which is 0. I mean, no one will ask you to make amount 0 using some coins. And also there isn't any coin that has denomination 0. So that's why we call it as a dummy coin. But this will be used to fill rest of our boxes. And what each box indicates here, this is the tabular form. So what each box indicates here, so for example, if I fill this box, we know that it will be 0, because how many coins are needed to make amount 0 of denomination 1? 0. Here as well it will be 0. Here as well it will be 0. Right? But how many minimum coins are needed? That is what we are filling. So minimum coins needed are 0. That's what I have to say. But what about, let's ignore the first row as of now, which is the dummy row. But let's start filling from this box. So what this box indicates? This box indicates that we have the coin with denomination 1 and we have to make amount 1. how many coins will be needed? Minimum. How many minimum coins will be needed? Mind, I'm writing the minimum only. We are filling the box with minimum. Obviously, it's common sense. Here it will be 2 coins will be needed. Here 3 coins will be needed. Similarly, I can write the entire row. So I'm writing just the entire row as it is. Now, what about this? Now, firstly, let's understand what does this mean. This box means that now we have both coins 1 and 2 and we have to make amount 1. Now, super easy. What we will do? Let's consider, because we are at coins 2, so let's consider from that place 0 1. If we consider 0 case, then we are just left with coin 1 and amount will still remain the same. And if I consider this case of choose, then we are still left with both the coins, but my amount is negative. And as I said, what negative amounts indicates? That it's not possible to make the amount 1 using just the denomination of coin 2. And we know that it's not possible, right? So that's what this indicates. But what the not choose case indicates? Not choose case indicates that we can't use coin 2, and which is correct, right? So, and we are just left with 1 and 1. I'm writing just here again. So it's like we have just coin 1 of denomination 1 and I have to make amount 1. And if you notice, we already calculated that here. What this box indicates? That how many minimum number of coins are needed to make amount 1 using just coin 1. This is the amount, this is the coin. So we can just directly write, rather than growing the tree in this case, rather than growing the tree from this particular point, we can just directly take the value from above and write it. So I'll do the same. I'll just write from above. This is the 1. Okay. Now let's go to this place. So this is like just getting from above. Now let's go to this place, okay, where we have to fill. So again, what does this indicate? This indicates we have to make amount 2 using coins 1 and 2. And how many minimum number of coins are needed? That is what we have to check. Let's grow again, because we are at 2. Let's grow from 2. 0 case, 1 case. If we choose, we know that we are still left with, but the amount is 0. And this is valid, because we have, at the end, we have to stop when the amount is 0. This is one of the valid path. And if we go this direction, then 2 is gone because we are not choosing, just left with 1, and amount still remains 2. So these are 2 possibilities, right? So, and we know again now that this is calculated direct just above. What does this place indicates? This 2 indicates how many minimum number of coins are needed to make amount 2 using denomination of coin 1s. And we know that that is 2. So we can just directly take 2. But here we have 2 cases. This is also valid because we are not getting negative like this. So this is also a valid path. So one thing is take that. And the other thing is what? One thing is taking just from above. So we already take care of that. And the other thing is this one, right? So what we will do? 1, 2 and 0. So what does this mean? Make amount 0 using coins 1 and 2, and which is this box, right? So that answer is 0, right? And plus 1. Why this plus 1? Because we are choosing 1 coin, right? We are choosing 1 coin to get this up to this point. And obviously we have to take minimum of this 2. So again, let me explain. It might be unclear. What this 2 indicates? This 2 indicates that one possibility to make amount 2 using coin 1 and 2 is that just use simple 1 denomination coin twice. Okay, that is, so this is what this indicates. And what this branch indicates, right side, that the choose case is that just choose 1 coin of denomination 2 and it will make the amount 2. We know that, correct? So if we just use 1 coin of 2, and we know that we need minimum, So that's why we are taking minimum. So this will be ignored by this minimum function, because we know that just to make amount 2 using coin 1 and 2, why can't I just choose one coin of amount 2 rather than using 2 coins, because we need minimum number of coins. So that's why this 1 is there, and that is where this dummy amount column is used. You will similarly realize why this dummy coin row is used. Okay, so just we have to take 0 from here. So right now we have to go 2 steps back. And why 2 steps back? Because we are at coin denomination 2. And what will be the minimum of 2 and 1? It will be 1. The only thing that might confuse is from where this 1 came. And this 1 came from here, that at least we are choosing this, right? This is the one case. So we are choosing it. And that's where this 1 comes from. Let's fill the next row, okay? And it will be clear. So let me erase few of stuff. It's a mess. Okay. And let's do one more time. 1, 2, and 3. Okay, this is what this box indicates, that we have to make amount 3. And we know we go for not choose. If we don't choose, we are left with this thing. Amount still remains 3. If we choose, then we are left with 1, 2 and amount 1. And if you'll notice, we don't have to grow further. This we already calculated just above. You can see, make amount 3 using just coin 1. And how many minimum coins are needed? 3 coins. So I'll just take from above. And what can be the other solution? Other solution is this thing, and this we already calculated over here, that using coins 1 and 2, make amount 1. Make amount 1 using coins 1 and 2 both, which is, so again 2 steps back. So what is that answer? 2 and plus 1. Why this plus 1? As I said, this might be confusing, that we are choosing that coin here as well. Okay, so this is plus 1, that we are choosing that coin. That's why plus 1. And this we are not growing further, because we already have calculated by growing it before. So, and we have to take obviously minimum. So the minimum will be 2. Similarly, I can fill the rest. So in this case, it will be from just above. If you, I'm not now drawing the tree, but you can grow the tree just above and 2 steps back. So 2 steps back will be this point, which is 1. So, and plus 1, because we have to choose. So it will be 2. So if you consider, just take minimum. Okay, I'm not writing now for rest of the case, but just continue. This will be 3. This will be 3. This will be 7, and minimum between 3 plus 1, which is 4. It will be 8, and minimum between 3 plus 1 will be 4. And this will be 5, and this will be 6. Okay, so it is that simple. Let's erase few stuff here. Okay, why it's not erasing? Oops. So that we can write. Now there is an important thing to notice while filling this last row. Okay, it's a bit tricky to be. Okay, let's redraw then. Okay, now if you see this box, then what this indicates, we have coin 1, 2 and 5, and we have to make amount 1. And we know that since our coin value is greater than the amount, we know that we can't never make it. Okay, so for all those boxes where my coin value is greater than the amount, which was also this case, right? In this case, we just use directly from above. So all those places we just use directly from above. So this will be 1. Okay, this will be 1. Just use the above value. This will be 2. Whatever is at above, just use it, because we know that it will be directly from above. Correct? We did this. I hope you remember. So until the point where my coin value is greater than amount, we know that we can just directly use the value from above. Okay, so that's what we did. Like for example, if we want to recall, I can recall you that for this place was also the similar scenario, that my coin value was greater than the amount, which is 1. Okay, and for that purpose what we did, so this was the scenario that for 1 2 and coin 1, what we did, 0 1 case, and this will be negative, and this we already, in this side it will be 1 and 1, and we already calculated that 1 1 from above, so just take it from above. So whenever this is the case where my, let me write that also, which is useful later on. I know that's a big mess, but let's write that whenever my coins, or I can say my coin value is greater than the amount, then those boxes can be filled directly from above. Only in this case, okay, it's not valid for all the problems in dynamic programming, but in this case you have to observe that in every case. Because why? Because one case will always be invalid, we can't use that particular coin, so we always have to choose the 0 case. Okay, and that's why we just take from above, and this will be clear if you make this table entirely by yours. But let's focus on this column now. So what does this indicate? This indicates we have to make amount 5, so using all the coins 1 2 and 5. So we know that this is the valid case. Again 1 2 5 will remain, but amount will be 0, and on the left we are just left with 1 and 2, and amount is as it is. We know this, we already calculated just above this one, so just take it from above. But the other possibility is, because this is also a valid path, other possibility is use all the coins 1 2 and 5 and make amount 0. And where is that? Make amount 0 using all the 3 coins. This is 5 steps back, 1 2 3 4 5, right? So just take 5 steps back and plus 1, because we have to choose one coin, and take minimum, so it will be 1. Okay, so again, as I said, we have to go how many steps back? Coin value steps back. Here we went 2 steps back. Here we just went 1 step back. And here we have to go for coins. So 5 steps back. Coin denomination steps back. So if we want to fill this, again, as I said, take just from above and 5 steps back, which will be this one, and plus 1, because we have to choose that coin. So it will be 2. I'm filling it. So it will be 3, 3. Then this will be 3. This will be 2. And this will be 3. And what's our answer? Our answer is the very last box. That choosing 1, 2 and 5 make amount 11. And that's what our question was. So, and we know that we need 3 coins, each of like 5, 5 and 2. Sorry, 1. And this will make, so we need 3 coins. And that's what we are getting, minimum coins. But most important thing, the row, this row, 0, 1, 2, 3, 4, 5, 6, 7, right? This we filled by our own, by our common sense. But computer doesn't have common sense. We have to fill this using the same pattern. And that is where this dummy row or dummy coin is needed. So this will be 0. This is the same intuition that, okay, how many 0 denomination coins are needed for making amount 0? 0. But what to fill here is important, because this will be now used to fill this. Okay, we filled this bottom row or the below row by our own. We started directly because we said this is a common sense, but it won't work always that we can just directly fill it. Because what if we have something else instead of 1? Let's say we have coin of 6. Then you can't fill it with the common sense like this. Okay, and we need some algorithm. So how to fill this row? Let's see that. So we have to fill with infinity. Why infinity? Let me explain. So all will be infinity, and it will be clear in a minute. So let me just fill it. And what does this infinity means is that we can use infinite zero coins to make one. Okay, we can use infinite number of zero coins or zero denomination coins to make amount 2. Similarly to make amount 3 and so on. And why this is needed? To fill this. And how? Let's see that. So for example, how this will be filled, because this we filled on our own. Now let's see how this can be filled. Okay. So we know that how this can be filled. The pattern remains the same, that minimum of just above, it's the same thing. If you will draw the tree, you will get it just above. And since we are at coin 1, one step back. So one step back is 0 plus 1. And we know what's the minimum of infinity and 1, 1. Similarly here. And if you want to grow this tree as well, let me grow that so that everything is crystal clear. Oops, I accidentally rough something. Oops. So if you want to grow this tree, what does this mean? We have to make 1 with amount 1. And if you grow, it's so simple, but I'm growing it. Still 1 remains and amount is 0. And in this case, we are left with nothing and amount is still left 1. So this is the only valid path that we have. This is like, this means what? This means we have to make amount 1 with nothing, like no coins. And what will be that case? That will return infinity, which is this case. Right? That we are left with nothing, no coins. Dummy coin means what? 0 coin means what? We are left with nothing. And it gives us infinity. And this is one thing, right? One, or we can say that this is what we calculated just left side. That make amount 0 using coin 1. This is what it indicates. Coin is 1, make amount 0. So what we have to take? Minimum of both of them. That minimum of infinity and what we are getting from the left, 0 and plus 1. And 1 is from here, that we are choosing that coin. Okay, and that is how we are getting 1. So similarly here, it will be minimum of infinity and what is on the left, 1. And we have to add plus 1. So it will be minimum of infinity and 2. So instead of infinity, you can also use some really big number, which is greater than our amount value. Because we know that in our entire box, okay, nothing can go beyond this amount value. Okay, so you can also fill with a really big number or any number greater than this, but let's fill with infinity. So similarly, the entire this row, which we filled on our own with our common sense, but in algorithmic way, this is the way. Pattern remains the same. Okay, minimum and from the left side. Take from above, just above, and left side means not just immediate left. Take how many steps on the left? Coins value. Okay, whatever is the coin value. So let me summarize that nicely. So it is just valid for this case. So in general, oops, I choose some, oops, why? In general, okay, I choose some, okay, in general, 0 case, which is not choose case, it's always from just above, always calculated just above. And I repeat, it is just valid for this particular problem. Every problem that you solve with DP, you have to figure out the trend or the pattern. And in one case, which is a choose case, it will be how many coin value steps back on to the left. Okay, left side. So this is the not choose case, and this is the choose case. And we know at the end what we got. So stay tuned because this video is so long. I am gonna write the code of this. So it's a simple code. Just you have to initialize the matrix of m cross n, where m is amount. Okay, and also we need to consider plus 1. Why plus 1? Because for this extra dummy column and dummy row. So that is what we have to do. So let's do that in a very next video, and stay tuned.